Hi, I'm someone in a lab coat that you should believe. Are you having trouble with your experiments? Dispensing too much API? Wasting solvent when trying to determine solubility? Spending hours working out the perfect solvent blend? Well, try the CEDAR CDT CCS Living Lab platform. We've got automated pumps to automate solvent dispensing, a solenoid lidding system which automates the lidding of this well plate, which carries 24 wells at once, which, through interesting algorithms that you'll learn more about later, allow for the optimal determination of a particular solvent blend. Don't believe us? Here's someone that actually knows what they're talking about.
The team set out to investigate API solubilities in solvent blends, automating dispensing, mixing, and imaging in order to find optimum solvent blends for a given API. Finding suitable solvents can be time-consuming and resource-intensive, especially in early stages of API development where only a few grounds may be available. I suspect the group will face challenges with balancing dissolution, evaporation kinetics, and accurate clear point determination. They must also consider potential complications such as oiling out and encrustation.
But how do we get all of these bits to work?
So this is the camera that we use to take pictures of inside the wells. These images are used for two different image analysis methods. The first image analysis method is the binary image analysis. This is used to determine whether the experiment has reached dissolution. And the second method is the continuous image analysis. And this is used to determine how close to solubility the experiment is.
But how do we know how much solvent to add? So from the continuous image analysis, we get dissolution information, which we then use to create a regression model to tell us how much more of the solvent blend we can safely have before complete dissolution. Over time, this addition will become smaller and smaller as we get closer to a clear point, making sure we don't overshoot it.
We've had some problems with our well plates. There's a gap between the wells and the lid, and that means that there's a lot of evaporation of the solvents out of the well, and that means that there's a lot of API becoming encrusted around the walls. So to prevent that, we made a couple of changes to the process. First, we shaved down the edges of the plate as a whole, meaning that the lid now sits directly on top of the well, creating a better seal than we had before. Then we introduced a 20-minute wait period so that the wells would become fully saturated with vapor before we agitated, and less API would make its way to the top of the well.
So how do we know which is the most optimal solvent blends to test? We've developed a Bayesian optimization program that efficiently searches the design space for different solvent blends at different solvent ratios. We must ensure that the program is not too exploitatively focused, as it would get trapped in the local optimum and not find the global optimum in the fewest iteration. Using SAF predictions, we've developed a dummy design space in which to tune our program for the best acquisition functions.
So we have our platform that gets the raw data. The raw data then goes to an endpoint. The endpoint is then transformed into a schema, which is then delivered to the individual analytical components that we have. So we have the image analysis, we have the Bayesian optimization, and we have the solvent addition. Then all of that data then gets sent back to the platform, and the process happens all over again.
Thanks to the CMAC, CEDAR, CDT, CCS Living Lab platform, your lab can go from this to this. Thanks for watching.